Use the fundamental theorem of calculus part 1 to find the derivative of the integral from t equal the lower limit pi over 2 to t equal the upper limit x squared cosine of t dt. This problem looks a little strange. They tell us to use fundamental theorem of calculus part 1. But here's exactly what that fundamental theorem part 1 says. It says if you call this integral a function of x, it would be the integral from the lower limit a to the upper limit x of f of t dt. But we don't have that here. Here we have what could be interpreted as the function g of x cubed, because the upper limit on our integral is x cubed. It's not x, it's x cubed f of t dt. So how are we going to modify the fundamental theorem to accommodate the upper limit not being x, but rather a function of x? Well, that would be g of x cubed. G of x cubed is a composite function. And what do we know about composite functions? They're asking us to take the derivative of a composite function. That means we have to use the chain rule. Anytime we take the derivative of a composite function, we have to use the chain rule. So how are we going to interpret that here in applying the fundamental theorem? Well, here I'll modify the fundamental theorem to see what it's saying. The derivative with respect to x of g of u, where u is a function of x, in this case is x cubed. Well, we let u equal a function of x. Then the fundamental theorem says if little f is continuous on the interval from a to b, that means the derivative with respect to x of g of u, where u, and in this case is x squared, equals a derivative with respect to x of the integral from a to u f of t dt, and fundamental theorem says that's f evaluated at u times u prime. You hit it with the chain rule of the inner function u, which is also the upper limit on the integral in this case. So let's just shave it down to exactly how I would answer this question. These simple two steps. Step 1, show f of t is continuous. Well, we want it continuous from the lower limit pi over 2 all the way out to infinity, since we don't know how far x is going to go at this point. So let's just think about the cosine of t. That's our little f of t. It's continuous everywhere for all real numbers. So of course, it's going to be continuous from pi over 2 to infinity. So that's taken care of. Step 2, apply the fundamental theorem part 1, but be sure to use the chain rule since the upper limit of our question is a function of x. Okay, derivative with respect to x of pi over 2 to x squared cosine of t dt is equal to the cosine of the x squared times the derivative of the x squared by the chain rule. So that is the cosine of x squared times 2 times x, bring the 2x in the front if you'd like, 2x times the cosine of x squared. So really, the way I would answer this question, I would read the question at the top. I'd go right down to step 1, step 2, boom, done.